One invention played a critical part in helping the Allies win World War II. Later, it improved the safety of air traffic and sea travel, gave us the ability to track storms, and changed the way we cook our food. It was one of the most important inventions of the 20th century. The term radar is an acronym for radio detection and ranging. Since 1941, radar has been used in English as a standard word. Radar uses electromagnetic waves to find an object's range, altitude, direction, or speed of objects, and can find other objects like planes, ships, cars, weather formations, and terrain. The idea of radar is based on reflection of energy. The radar transmits a signal, and then the signal reflects back to the radar. The stronger the reflective signal, the larger the particle is. We have strong reason to conclude that light itself, including radiant heat and other radiation, if any, is an electromagnetic disturbance in the form of waves propagated through the electromagnetic field according to electromagnetic laws. James Clerk Maxwell, 1864. James Clerk Maxwell discovered the laws that govern how electromagnetic waves work. In 1864, he wrote a paper called A Dynamic Theory of the Electromagnetic Field. Many people recognized the importance of this discovery. Professor R.V. Jones commented, "This paper is the first pointer to the existence of radiation other than light and heat, and ranks as one of the greatest leaps ever achieved in human thought." His discovery made possible the invention of radio, TV, and many other electronic devices, including radar. Heinrich Hertz experimented with the RF waves James Clerk Maxwell had described. In 1886, he invented the radio wave transmitter. This later became a key part of radar. Wireless technology was one of the discoveries needed in order for radar to be invented. Guglielmo Marconi was one of the first to use wireless technology in a practical application. Carl Ferdinand Braun invented the cathode ray tube and oscilloscope in 1897. The oscilloscope is the key part of radar. It is the radar screen that displays where objects are. The oscilloscope is one of the most widely used electronic devices. Now, most of the innovations were in place for radar to be invented, but history was about to show how much an invention like radar was needed. One clear night in April, the Titanic sunk. Fortunately, 705 people were saved. This was possible because of Marconi's wireless invention. The message sent without wires was, "Come at once, we have struck a berg. It's a distress situation, old man. Position 41.46 degrees north latitude, 50.14 degrees west longitude." The sinking of the Titanic was shocking to people because it was considered unsinkable, and many rich and famous people were among its passengers. The sinking of the Titanic showed the world that a device that could warn ships about obstacles was needed for safety. Marconi recognized that such an invention, now known as radar, was possible. In a speech to the Institute of Radio Engineers and American Institute of Electrical Engineers on June 20, 1922, he generated a lot of interest in developing radar when, after describing some of his experiments, he concluded, "It now seems to me that it should be possible to design an apparatus by means of which a ship could radiate or project a divergent beam of these rays in any desired direction, which rays, if coming across a metallic object, such as another steamer or ship, would be reflected back to a receiver screened from the local transmitter on the sending ship, and thereby immediately reveal the presence and bearing of the other ship in fog or thick weather." Robert Watson Watt is considered to be the father of radar. On February 12, 1935, he sent a secret letter to the Air Ministry in England titled, "Detection of Aircraft by Radio Methods." This led to his famous experiment 14 days later called the Daventry Experiment. On February 26, 1935, Robert Watson Watt set up and tested the very first radar in a field near Daventry, England. He had a bomber fly towards the radar. It was the first day that radar was successfully demonstrated. Robert Watson Watt began developing a radar that would protect the coast of England from attack by enemy airplanes. The radar that he developed was called Chainhome. It helped England win the Battle of Britain in 1940, preventing the Germans from invading England. In the following interview, Robert Watson Watt describes the development of the Chainhome radar.
In July, we had a tremendous stroke of luck. We sent out an aircraft, which we tracked out to 25 miles or so, and it then, by instruction, was to go much further off so that it might come back at an unexpected time. And suddenly, a new group of echoes appeared on our screen, and we said, this can't be our guy unless he turned back too soon. And then we said, Wilkins and I were looking at the tube together, we said, this is a formation of aircraft. And in fact, it's a formation of three. By November, we had shown that the direction finding would work all right, so all the three elements, distance, direction, bearing, and flying height, were now measurable.
During the Battle of Britain on August 20th, 1940, Winston Churchill, Prime Minister of England, made a speech to the House of Commons thanking the people involved in providing to the air defense of Britain.
The gratitude of every home in our island, in our empire, and indeed throughout the world, except in the abodes of the guilty, goes out to the British airmen who, undaunted by odds, unwearied in their constant challenge and mortal danger, are turning the tide of the world war by their prowess and by their devotion. Never in the field of human conflict was so much owed by so many to so few.
What Winston Churchill could not say in his speech was how important radar was to the airmen, because radar was still secret at that time. At Robert Watson Watt's funeral, it was said, more than any single endeavor, it was radar that brought us through the war to ultimate victory. The way that meteorologists forecast weather was forever changed by radar. Before radar was invented, people often had to observe the weather to try to predict what the weather would be. This was far less accurate than the radar because you can't see what is coming, unlike with radar. In an interview with Greg Shore, a meteorologist with the Baltimore-Washington National Weather Service, he described how Doppler radar has helped society by giving us the ability to track severe storms or tornadoes before they happen so we can stay safe. Radar has greatly improved air traffic and sea travel safety. In 2008, there were over 8 million flights, and today, over 99.99% of them make it back safely. This wouldn't be possible without radar. Radar also helps keep boats and ships safe so they don't sink. Radar has led to the invention of the microwave. The microwave was invented by Percy L. Spencer in 1946. It was invented by accident when he was experimenting with the cavity magnetron. He happened to have a candy bar in his pocket, and he noticed that it was melting. He tried cooking an egg later, and the electromagnetic radiation cooked the egg. Microwave ovens were available to consumers starting in the 1950s. The innovation of radar has made an impact on history. Radar has changed everyday life. In America, 95% of the households now have a microwave oven to cook their food quickly to match a fast-paced lifestyle. Even in language, the expression under the radar is commonly used to indicate when something or someone is undetected. Every night, people rely on weather radar to tell them what is going to happen with the weather. Every day, approximately 6 million people fly in commercial airplanes and rely on radar to guide the planes safely. Radar was invented because there was a need to protect people from enemies. There is still a need for this, and there are many types of radar used for national defense. Radar also helps the economy. The radar industry is expected to make over 11,000 radar devices from 2007 to 2016, worth $50 billion.